And all you need to do to generate an electrical field is have a moving magnetic field. So if you can move magnets, you'll create an electrical field. And, if you, and they move the magnets right in front of these coiled wires, and they can harness the electricity of just moving magnets, just an electrical field. That's all there is to it. They don't need any.
That is the generator.
This is the generator right here. Just the magnets and the copper wire coils. And they coil it up because you can collect more energy based on how many coils you have. So this is the entire thing. You just put magnets and coiled copper wire together and use some power to move the magnets around. And then you just draw the electricity right off of the coils. And so the wind generator, they just put them on blades and raise them up high. Wind does all the work.
So is it more efficient than the standard wind generators?
This is a standard wind generator. It's just a matter of, all the wind generators use the same principle. It's just a matter of how big the magnets you can buy, how many coils you can get, how high you can put your blades.
The main advantage is that it's something you can build yourself. So it's somewhat adapted design for being able to build yourself rather than a commercial one which requires more like complicated machinery. As you can see, like we just wound these coils by hand. So it's kind of an open source design that's been developed kind of just by people that have been doing it themselves in various communities and things. And we were kind of surprised at how easy it is. It's actually not that difficult. As you can see, it's just a few components to put together, and you know, you have something that will produce energy for the next 30 years. So it's pretty cool.
What was the cost of this one?
The cost of the generator itself was around $400 or so. The advantage of this design is you can do a lot of scrap type stuff. I mean, you can get a lot of things from scrap metal. We got this bearing, for instance, from a junkyard for an old van, and so it can be relatively inexpensive because most of the metal components you can scavenge. So it's not that expensive. 2,000 to 3,000 watts and like a 40-mile-an-hour wind, something like that. Obviously the average power output is going to be quite a bit lower than that, but this is about the size you would use for an average home. So, yeah.
So $400 generator.
Yeah.
By an average home.
I mean, it's a lot of labor, but if you don't mind doing it yourself, it's a cool project to do.
How much labor was it?
It's probably, I mean, you could build one of these and a few people working for a week, basically. And I mean, you can do many at a time, and that makes it a lot faster because you can just do I mean, it's always a little bit longer when you do it the first time. And once you get, I mean, there's guys that do this in communities and they just turn them out. Like every week they build like 3 or something, and then they can power all their neighbors' houses, and just like, it's like a virus that keeps spreading. They just keep spreading how to do it, and people keep building them. So it's kind of an exciting thing that, I mean, you can really like achieve energy independence with something you can do yourself. I mean, solar and everything is really cool, but it's not as much of a do-it-yourself kind of project. I mean, this is something it's not kind of requires minimal metalworking skills, and that's about it. So it's really neat.
Is there a way of gauging how much wind is enough wind in your area, for example?
Yeah, there's actually, well, at least for Iowa, there's the Iowa Wind Calculator. And I think they have similar things for other states where you can go online and you put in your city and state, and it will give you, and you put in your tower height, and it will basically tell you for different turbine sizes how much output you're going to get. So it's kind of a real handy tool to use, and you can, I mean, if you want to do a really detailed study, you do like an anemometer and you take measurements for like a year, because every site is a little bit different. But that, I mean, the online tools will give you a pretty good yearly estimate. So that's a real nice, handy thing to have.
Whatever, I'll just run it. There it is.
I'm gonna put it through this hole, and you put that little thing through the center point here. Okay, well, the magnets are going to want to catch, but that's okay. I just keep going up.
Okay. Does that screw in there?
So actually, what we want to do is, take your end that way a little bit. There we go. just keep shifting it around a little bit. There we go.
Oh, I see. Yeah, you've got.
Oh, yeah, the blade, we had to take this down for repairs because the blade hit one of the guy wires. So we, what we did was increase the spacing here. We put the generator a little bit farther out to prevent it from hitting the tower. So we just took it down, repaired the blade with epoxy, and putting it back up again. So we put this thing in. This holds it, prevents the thing from coming loose. We put a little lock nut, it's called.
Oh, I see. That just goes down anyway.
The tree sure did grow a lot too fast.
I know. Yeah, we'd have to move it a little bit.
Looking good. Julian weightlifts all year just to be able to do this.
Well, I've probably done this about at least 10 times. It's just hard to take it down. Yeah, it's hard.
What did we got this?
It was probably. It's a mindfulness thing.
Oh yeah. Hey. So that's hooked up, right? That's like feeding the place, right?
So what does open source mean?
Well, it just basically means the designs are on the internet, anyone can contribute, and basically everything's available for free for everyone. And the cool thing about it is it's kind of like a community of developers testing it and putting in design inputs. We actually took a design that was available on the internet. So that's the cool thing about it. It's just kind of a community of people working on it and just kind of all helping each other. And there's kind of it's a cool online community doing these kind of things, and really it's really neat. They have all the resources and everything for it. So.
Excellent. Can you give any of that the web addresses? Or?
Yeah, the site we used mainly was called otherpower.com, and or I think it's .org, otherpower.org, and they have tons of resources on the different turbine sizes they've done. They've done some that have been I think 25 feet in diameter, the same design, that have been like twice the capacity of this. So they're like one of the main sites for working on that kind of thing.
Excellent.
So yeah, so it's exciting, and I'm just looking forward to building my next wind turbine. I mean, it's kind of like every time you do it, you want to refine it a little bit more, and you get more ideas, and you can try something different every time. So it's a lot of fun.
Excellent. Good job.
If nothing else, it's just a fascinating way to monitor the energy of the wind in general. You take it for granted, how much different, every second it's so different.